Hi, everyone. Thank you. My name is Ben Actis. This is Pwn All the Porn Apps. Thanks for having me at BSides Vegas. I'm super stoked to be here. A little bit about me. I started my career at MITRE, which is a federal research lab. I did a lot of mobile security there. I also did a lot of network sensor work as well. Then I went to Lookout, where I reversed thousands of Android malware samples and some iOS ones as well. Then I spent a year and a half at Synac, where I helped build their mobile attacking toolchain. So how do you at scale reverse apps, statically look for vulns, dynamically look for vulns? I also did a lot of mobile pen tests there too. All of the work today is done under my side business, Cyber Merchants of Death, where I do a lot of bug bounties and training in this area too. So a little bit outline, we'll go through the motivation, a little bit of Android 101 so you understand some of the vulns if you're kind of a novice. Then we'll go through 3 vulnerabilities in apps and easy fixes. So motivation here, we're all humans at the end of the day. Some of us have sexual urges, and some of us choose to use adult content or pornography apps to meet those urges. But the privacy of these apps are pretty important, right? And there can be some serious consequences if our usage of these apps are inadvertently leaked to others, right? One such example, this is from the New York Post. Users were targeted with a malicious application. The idea was users would be tricked to installing like a video codec or an adult content app. What this app would really do would film the user without their consent, right? And then a video would be used to blackmail them and say basically pay me $500 or I share this with a bunch of people. Right? So as you can imagine, this would be really damaging to relationships, professional ones, kind of you name it. But in addition to the privacy violation, there's also an actual physical human impact here. Egypt actually leveraged improper implementation, some of the GPS functionality of Grindr to actually track gay people, and those people were actually injured and killed in some cases. So there's big impact here. So, are these apps secure? Now, before I go forward, I have to cover a few little Android things here. By default, your Android app has a little protected storage area that only that application can access. If you ask for the external storage permission, you can write to, typically it's the SD card. And that storage is world readable and world writable. What I have up over here is the actual screenshot from the API docs. And they actually say there in the first paragraph, do not store any private information here. Right? So anything that could identify a user, photos, etc. They also go out of their way that says you should never write executable code here because any other application on the phone could read that code, modify that code, or delete that code. The other important thing I want to cover is on Android, it's really simple to do HTTPS now. As long as your backend supports it, it's as simple as just doing HTTPS in your domain. Right? It actually says it right there in the docs. Yes, it can really be that simple. Now, this isn't going to do your certificate pinning or your key validation, but at least it's something. So the problem is, if you're a pornography app, you're banned from Google Play. So you can't leverage that update mechanism, so you have to roll your own. The problem is, if you go to Stack Overflow and search like how to update non-Google Play app, you get this example here as the top one. And this is a poor implementation because it says, oh, just write to the SD card, right? And we just saw from the other slide, Google tells you in the APIs, you should never do this. So let's look at some vulns here. The first one is known as Planet Prawn. According to their website, they have 1 million satisfied users, 200,000 video and picture sets, 400 professional partners, 30 plus amateur partners as well.
How many unsatisfied users?
It says 1 million, which is funny because if you look at the tokens later, like the unique user IDs, we're not at 1 million. So anyway, it's true, right? Now maybe that changed since I reversed it, but anyway, Android Central says the quality is there in the app and the content. Android Authority gave them good reviews, and also Fleshbot too. So vuln number 1. This is man-in-the-middle proxy, in case you're not familiar with it. It's most commonly used for intercepting and viewing HTTPS traffic, but in this case, it's HTTP. So a few things here. You can see my username and password. Also, there's this T value, which is the integer I was alluding to earlier. The reason why that's a problem is if you actually look at how the app does its change password or change email field, it doesn't check your username or password. You just need that token value. So if you knew that, you could change people's passwords. So the other problem is this application, because it's all in plain text communication, anything you search for, any private messages to other users on the site, anyone could see that, right? So that's not good. The other problem, which is more interesting in my opinion, is can we replace their update app? Because they can't be in Google Play. And how this works is, I have some decompiled Java code up here, is in this red rectangle, you got a string, and it's getting this string from the Android manifest. For those of you that don't know, the Android manifest is kind of like the table of contents in an Android app. And all this is doing is saying, hey, look at this version name, store it in this string. So in this case, it's 2.07. Then what it's doing is calling this check for app updates method. And how that works, it goes out again over HTTP to planetprawn.com/app/version, gets a connection, and returns a numeric value. And here's what it looks like. Again, HTTP. Now, if we're a network-capable adversary, we can modify these things, right? And I'll step through that. Oops. So at this point, what you're doing is just comparing, right? Like if the client's outdated compared to what the server tells us, then go through this update path. And how this works is, again, it's going over HTTP, goes to just planetprawn.com/planetprawn.apk, and then it just installs the APK there. So here's a little proof of concept video. Man in the middle, proxy in the back, Android video in the front. And if you see the orange font, I've set up a intercept filter. So basically it says pause this traffic if it matches this expression. So it goes out to Planet Prawn, gets the version, I allow the request, and now I'm going to modify this, right? So the server's saying, hey, my latest version is 2.7. I'm going to say, no, it's actually 2.9. Save it. Now I'm going to allow this modified response back to the client. At this point it says update available, and I zoomed in here because I edited out a lot of the adult content. Yeah, sorry guys, I had to get it through PR.
Okay, if you can't find porn on the internet, go home.
Yeah. Yes. So anyway, so now it's going out to the server, right? So at this point, you can do a few things. The easiest one for me is I'm just going to change the URL it goes to, but you could do DNS poisoning. You could actually just modify the zip or the APK file that comes in at this point. But I'm just changing it to a subnet on my local IP, and I'm calling it planetprawn.apk, which is not the real one. At this point, it's being downloaded. I'm saying, hey, open it, open the top one. And at this point, the icon's different, right? Installing. I open it, and boom, not the porn you're looking for. Yeah, so obviously this is not the legit app, right? So if I was an adversary, I could do a lot of things at this point, right? Worst case, I could replace it with a rooted version of the app, right, where I try to root your phone with an exploit and persist that way. I could add additional permissions, like camera and things like that, and just kind of shove it into the binary so it looks like the real one, but I'm actually doing other things in the background. And even worst case, if I don't have any new permissions, I still have read external storage. So I could like kind of peruse external storage looking for embarrassing photos or something. Third vuln, they're storing this update file in a world-readable, world-writable location, right? So if I'm a malicious app, I could just watch this directory and swap it out that way too. So the vendor was actually really positive. They basically thanked me. They said, we're going to fix it ASAP. Andy replied. I don't know what Andy's role is, but he wanted to fix it, so cool. Disclosure timeline, I emailed them end of the month. They actually responded, I think, within an hour, which was great. It still hasn't been fixed yet, but maybe this morning they did, so we'll see. So they're doing insecure communication. There's no integrity check of that update file, and they're saving that update file on external storage. So next one, Perfect Girls. This one's kind of funny. So if you go to their website, they're mimicking Google Play, but this is actually not Google Play, which is really funny. Second thing is they have fake reviews, and if you go in the source code, it's just like hard-coded values in here, which is also really funny. It gets better. They reported the app as Porndroid, which is not the name of the app, and this was actually a piece of Android malware from like 2 years ago. The other funny thing is they have like fake reviews. I don't know why they put like a fake, can you help me reset my password review? I don't know, I thought that was funny. So vuln number one for Perfect Girls. This one how this one works, the client sends its version out to the server, and then the server replies. So this one's saying, hey, I'm running version 2.09. The server responds with two things this time. One, a Boolean value, true or false, that says, is there an update available? And two, a version number. So here's how this works. So the first check is that Boolean, right? Is an update available, true or false? And I'm going to go through a little bit of Android assembly here, just because we're going to debug in a couple slides. So this if statement becomes 3 lines right there. So it's basically get a Boolean, and then if that is equal to 0, go down one path. If not, go down the other path. Then there's the second check, that numeric one. And this value is actually hard-coded as a string in the app. It's not in that manifest file. And it's just saying, hey, if my client version is outdated from the server one, then go ahead and do an update. And again, this one if statement comes about 4 lines because we're comparing floats. And then it does a difference, and if that difference is equal to 0 or less than equal to 0, go down one path, otherwise go through another path. So this should be super easy, right? Because like the client's app's already outdated. So I'm like, okay, cool, it's going out. Client's saying it's 2.09. Server says the new one is like 2.10 or something like that. And I'm like, great, this should be the most easy POC ever. So I'm allowing it, allowing a bunch of other things, and it failed, which is really weird. So I start changing and incrementing and decrementing everything on the client end and everything on the server end, and it still wasn't happening. So I'm like, this is really weird, right? Because I told my mentor for this talk, like, this will work, right? So I start going through it, and I'm like, this is weird. This is really strange. That second check, I'm getting the same value twice. So their update mechanism is actually wrong. They compare the client version twice instead of the server one. So their app will actually never update, which is hilarious. So we have IDA Pro, so we can patch their binary. So if they fix this conditional check, they do update, which is great. So we can also do debugging in IDA Pro with Android, in case you guys aren't familiar with that. So what I'm basically saying start debugging. Any of those red lines are breakpoints. So I basically set a bunch of breakpoints right where that first Boolean check is, and then where that numeric check is, which you'll see. And a blue line will indicate that's like the current line we're executing on. And don't worry, I zoom into IDA when it's funny values and stuff. So it takes a second. Now it's launching. Okay, so it gets the client version correctly the first time for the Boolean. Now it's getting values from the server end in the background. We're at the first Boolean check right now. True value. Everything's coded correctly here. It's getting the new values from their server. Right? And we're going to go to the left of execution over here because we got the right Boolean value. It's going to pop over here. Gets the client version. And now this is where the mistake is, because it gets this value twice, right? One of those should be 2.1. So all I did was, IDA, I just said, okay, you're now 1, and it's going to go down the update path. So boom, hit continue execution here. It's going to run. And there you go, 2.1 is available. So go ahead, hit download new version. And pow. And I'm going to zoom in on a second here. You can see what I'm doing. So similar kind of attack here. Instead of going to the legitimate update server, which is also HTTP, I'm just going to go to a server I control. I think I call it evil.apk here, and download it. Now, you could also, again, like I said, change that APK in transit, so you won't even see a change in address. You could do it that way. And also DNS poison and do a bunch of other stuff here too. So at this point, the app pops up, and I had to edit out a bunch of adult content here. So enjoy kittens. So now it's running, it kind of relaunches, and then the update prompt comes. And boom, not the porn you're looking for. So now this one also writes the SD card, which is bad. So disclosure, I emailed the company, and I haven't heard anything. I even checked my spam folder this morning, so I don't know. So perfect girls, HTTP usage. They're not hashing any kind of integrity check, and they're also writing to external storage. So Pornhub. Most of you are probably familiar with this one. The good news is they are using HTTPS, right? Yeah, they have puppy videos on it. And they are doing a hash of the APK being downloaded. The problem is, as you'll see here, how it works is it goes to a URL, says, hey, what's the latest version? And then it's going to reply back if it's out of date, the new APK, the link to it, and then an MD5 with that file, MD5 of the new APK, and a file size. The problem with is you're sending the new file size and hash in a mechanism which is, as an attacker, I can see, so it's trivial to change. At this point, this file is written to external storage, and then they're just going to compare them, and if that matches, then we're good. So all I'm modifying, so what I did was I put a fraudulent cert on the device so I can intercept traffic, right? And what I ended up doing was just change it to a value or a server I control. I'm changing the file size and the MD5. Pretty easy. So here's an example here. And I'm sorry for the potato quality in this video. My screen recorder binary crashed. So I'm going out. It's talking to Pornhub right now. Now at this point, I've deleted the legitimate values and I'm putting my evil ones, right? So put in my evil MD5 hash here, the new file size, and an evil URL which I control. And because these are the values the client checks, it assumes everything's good. And at this point, it's updating. Now it's going to my evil URL to get the new update APK. Boop. Download. And it should pop up in a second here. Now you could do all this just with scripting man-in-the-middle proxy or a little bit of Python. None of these attacks would require like human intervention. Hit install. And open. Cool, right? So Pornhub is a bug bounty. I'm like, awesome, this is really cool. I can get paid for finding these vulns, right? So I submit it, and they're like, hey, cyber merchants of death, thank you, but your update URL is actually not in scope. So we're not going to reward you. And I was like, this sucks, but okay, right? But then I was like, wait a minute, they're still writing to the SD card. I wonder if there's a race condition there. So what I did here was there's that check that I mentioned. I called it checksums check. And what this is doing is going into this bit of code, and all it's doing is getting the file size and the checksum. So it's pretty easy. Then if that condition is met, then it goes ahead and installs the APK that's downloaded. So if I'm an attacker adversary, this is kind of the period of time where I have a race condition, right? So let's do this. So I did it with a debugger just so I could extend that race condition to an unlimited period of time. So I'm doing debugger, start debugging. I'll start up in a second here. Now on Android, you can debug in a few different ways. If you want to cheat, you can take the app, decompile it, add a single flag, and then re-sign it. That's one way. But your signers are not going to match because it's public-private key crypto. The other way is you can have a rooted device and you can launch anything as root and then attach. Or if you really want to get savvy, you can actually recompile Android from source and change some stuff. So right now it's running, it's doing the update, and I set a breakpoint right where that check occurs. Right here. So at this point, the app is validated, the APK on external storage. It inherently trusts it. And what I'm doing here is I'm just removing their legit app, and I'm copying the name of my like jokey app to the same name that the client is expecting. Right. And then I'm going to enable execution again. And boom, it's updating. Cool. Installing. And also, by the way, you can change the little app icons and shortcuts. I was just being lazy. Cool. All right, so I submit this one, right? So the vendor kind of went back and forth for a while, I think 2 or 3 months. Eventually, I ended up talking to a nasty Nick, who was their main Android dev, I think. And he basically said, hey, thank you. We're aware we're storing things in common ground where other applications can hijack the APK. Sadly, there's little we can do to resolve this issue because of the nature of how we distribute. And I was like, hey, I'm sorry that Google's being unfair to you, but have you considered using these protected storage internal APIs? The difference being like instead of get external dir, it's get dir. It's actually a pretty easy change. At this point, their bug bounty triage person replied to me, do you mind if we close this as informative? And I replied, yeah, I do. I'm a little confused here because I gave you proof of concept video, I gave you an IDA Pro database file, and I cite like mobile OWASP guide saying you really shouldn't write to external storage. I'm confused why this doesn't count. At this point, I think a legal person on their team or someone wrote me back that said, since you're quoting our EULA, let me do as well. We reserve the right to pay whoever we want. We don't think this is a vuln. There's going to be no further negotiation. So I told my girlfriend, all right, I will give a B-Sides Vegas talk then. So, yeah. I joke, but like these are like really bad flaws, and they really should fix them, right? But anyway, so disclosure, first vuln comes out 12:10, then on 12:20, yep, they marked as not in scope. Then I submit the new vuln. Then we actually go back and forth for a bit, which was actually fun. February 1st, dev says it can't fix. A week later, they said, sorry, go away. And then 6/28, they say, hey, I'm going to go public about it. So the other question is, could we do this without a debugger, right? So this is a really neat app, File Observer. Who knows about iNotify in the audience? Some of you? Yeah? Okay. So one of my old school like graybeard Unix mentors taught me about iNotify, and it's super cool. Basically, it leverages the kernel, and you can basically say, watch a directory for a file change. And you can watch for a lot of different things. Here's all some examples. So you can say, like, tell me when a new file is created, such as update APK. Tell me when something is written to a file. Tell me when a file is closed. So what you could do as an evil app, you could get external permission, and then just watch the SD card, and you would watch for the writing of it, and then reading of it, because remember it reads file size and does a hash, and then you would just do like a symlink really quick. So that's how you do it without a debugger. So Pornhub, they are doing HTTP, which is awesome. They do, HTTPS, thank you. They are doing an integrity check, which is good. There's improvement on both of these, but it's something. But they are still writing to external storage. So the fixes for these are super easy. Use HTTPS, ideally, doing key pinning and checking your certs, and do not write files to external shared storage. You could write it internally, and there's an allow installed apps or installation of other apps permission. If you want to get really crazy, you could use some native code and patch this stuff in memory if you wanted. There's a lot of things you could do here. So I also want to thank my mentor, Brandon, for a lot of help and mentoring on this. And yeah, let me know if you have any questions. My email is ben@cybermerchantsofdeath.com, or you can follow me on Twitter at benra. Yes, question in the gray. Oh, thanks.
So you said that each app has its own special place where it can store things.
Yep.
How big can that space be?
As big as you want, right? So the original idea was like a lot of Android phones had really, really tiny like protected storage, and you had big storage for like other things. Most of the phones now, even like the $50 Amazon ones, you have like 40 gigs available for internal, right? Yeah. Gentlemen and the,
With regard to installing your evil APK, isn't that getting installed side by side with the existing app, because you're not able to spoof their signature on their APK, right? Otherwise, it would, like if you try to use the same bundle identifier.
Yeah, but they don't check the signature, right? So what's really cool about Android, though, right, is it's public-private key crypto, right? So unless they lose their private key, I can't masquerade as them, right? So smart developers, right, like the ideal way of doing it is you would check for that, right? Instead of doing like the hashes over the air, that'd be a better way of doing it.
So you are able to overwrite their APK when you install your evil one then?
No, both would exist, right?
Okay.
You could probably delete things in such a way where that wouldn't work, right?
Okay.
But great question, though, by the way.
Thanks.
Any other questions?
No. All right.
Thank you
Cool.
all.
Hey, thanks for coming.